A relatively new tool in the University of Florida research arsenal against Laurel wilt is the Hypergator supercomputer. This cluster of the latest generation of processors utilizes artificial intelligence, or AI, to achieve computations that offer UF researchers to share enormous amounts of data at ultra-high speeds. Taking advantage of this resource is plant pathologist Garret, whose work at UF-IFAS extends beyond the here and now. She's using the network to assess damage from diseases such as Laurel wilt. Her work with artificial intelligence is called network analysis, and deterrence is its objective.
AI is important to my work because we're often dealing with scenarios where there are many potential predictors, and we have to sort through those all. So machine learning is an important tool for helping us figure out which variables are important as predictors to help us understand the system and to incorporate those into the kind of models that we create for decision support.
Those models are determining how Laurel wilt behavior is likely to change under widely varying conditions. To Garret, finding the answer to one question is paramount.
How would it tend to spread based on what we know about it? And then we've got the observations of people in Florida. So we can observe what's happening in Florida and then also think about how to extrapolate that to other places that it's not present yet, to understand what people there might be able to do to help contain it when it arrives there.
Ironically, a recent human-based epidemic, COVID-19, has caused people to take an interest in and better understand how human and plant viruses spread. Garret says fostering that understanding globally is vital to food security.
Because of COVID-19, almost everybody is thinking about epidemics in one way or another, and so it's really increased people's awareness of epidemic risk, and it provides a lot of lessons for thinking about how to manage epidemics better. For example, when there's a new invasive pathogen, it's really important to try to deal with it quickly because, of course, if you think about a network, as it spreads further through that network, it's going to be harder to contain it. So that's an important lesson from COVID-19 and from most plant diseases, too, to take quick action to contain a new invasive pathogen.
Garret describes Laurel wilt in South Florida as an invasion. When asked if group behavior of avocado growers is affecting management decisions, she likens variability of their responses to differing group attitudes about COVID-19 vaccines.
When you're thinking about an infectious disease that's spreading, if there's, for example, an abandoned grove where there's a lot of disease building up in that grove, then that's a threat to the neighbors, right? For the disease to spread to the neighbors. So that's the problem for an epidemic, right? Is that one abandoned grove can be a source of risk for lots of other groves nearby it, and then that effect can spread throughout the epidemic network.
Garret says reducing that possibility depends on rapid analysis of data. She and her research assistant, Maria Etherton, are utilizing AI by applying a modeling term called scenario analysis. This analysis involves the choices to consider and what happens when variables are applied to them.
This decision support tool can be used by policymakers to see how their types of policy, potential funding amounts, can benefit a region during an epidemic. And growers can also use the software to see how potential management strategies, when implemented in their grove or across a region, can influence the region's health during an epidemic.
Garret says policymakers are sometimes part of a problem within the system. She says too much spread is likely with their typical "let's wait until we have all the answers" approach.
Quick action is really important because of the multiplication through the network, the epidemic network. So that's important to, I think, for example, help policymakers get over the hump of action, because a natural reaction when there's a new invasion is to want to get more information, but usually some action needs to be taken before people have complete information. So that's the challenge for invasion management, acting quickly enough and figuring out a good strategy even without complete information. One option is to support growers. For example, with laurel wilt, removing diseased trees can reduce the risk of spread. So that's one possibility, is for government agencies to help support the removal of trees.
However, more questions may arise, such as who removes the trees, when do they do it, and who pays for the removal. Garret explains one model being developed will show probabilities of successful outcomes to different strategies.
So, for example, if a grove is abandoned and not managed, then there are options like increasing the tax rate for that grove and so on. So that's one of our interests, is developing models of the system so we can give feedback for government agencies about the likely outcomes were they to try these different kinds of strategies to help manage the laurel wilt epidemic.
As we've seen, one of the applications of artificial intelligence can serve as the basis of a call for action. Championing the call to save South Florida's avocado industry is Tropical Research and Education Center Director Edward Gilly Evans, who conveys glasses better than half full optimism. He and data management analyst Freddie Balin are up next in our concluding segment, Economics of Laurel Wilt Impact.